In this video we will learn how to compare natural numbers and, no less important, we will solve very interesting problems on this topic. Since natural numbers in most cases show the number of objects in counting, one of two different natural numbers is always greater or less than the other. For example, 25 is less than 26, 632 is less than 970. 245 is more than 155 and 1320 is more than 956. In order not to write million times more than or less than, mathematicians have come up with the appropriate signs with which they write the result of the comparison. All expressions in which these signs are encountered will be called inequalities. In order to better remember in which direction write the sign, note that both signs supposedly form a triangle, where on the side of the smaller number there is one vertex, and on the side of the larger number two. That is, more vertices correspond to a larger number. If two natural numbers have a different number of digits, then the one with more digits will be larger. For example, 25 is less than 113. 3028 is greater than 995. 8694 is less than 10,120. And 100,001 is greater than 99,999. At this stage, it's very important not only to remember the rule and then say that the teacher told me so, but to try to find logic and understand why it could not be otherwise. For the same number of digits, compare the digits of numbers from the largest to the smallest. For example, in order to compare these two numbers, first let's look at the thousandths place. And since 8 equals 8, go to the next place, saying that 6 equals 6. We actually say that 600 is the same as 600. Then we see 5 is less than 7, which means 50 less than 70. And at this moment we understand that 8,670 is more than 8,654. More than two numbers can be compared. For example, comparison of three numbers is called double inequality. Let's write a few examples where you can stop the video and make sure they are correct. Finally, we come to the practical part. In this task, you need to compare the values of the expressions. At first glance, we don't know how to compare expressions, but it's not difficult to see that the result of each expression is a number. All that needs to be done is to find the value at the left and the right expressions and compare the results. 25 times 3 is 75, and if we add 36 we get 111. And 12 plus 35 is 47, and multiplying 47 by 3 we get 141. Using the algorithm for comparing numbers with the same number of digits, we will see that 141 is greater than 111. And we can even say that 141 is more than 111 by 30. In the second task, first we perform division on the left side of the inequality, then subtract 23 from 41, and we get that the result of the left side will be the number 18. Similarly, we can calculate the right side, where we first perform the action in parentheses and only then divide by 9, and we get the result 17. Note that the left side is larger than the right side, and move on to the next question. It is necessary to write the conditions in the form of a double inequality. In the first point, for example, saying b is greater than 4 and 17 is even greater than b, we conclude that 17 is the largest number, 4 is the smallest number, and b should be in the middle. In the second, d is greater than 8 and less than 32, so this is any number from 9 to 31. We write down the corresponding inequality. In the third, c is less than 13 and more than 7, so this is any natural number from 8 to 12 included. And you can write down the desired inequality. In the fourth part, x must be between the numbers 10 and 12, so there is only one value for it, namely 11. We write down the corresponding inequality and go to the next task. As you can see, each item contains two numbers in which instead of several numbers they put asterisks. It's necessary to compare these numbers. For example, in order to compare the first two numbers, first we will see that they are both 5-digit numbers, and the first digit is 3, which means 30 thousandths, they have the same. We pass to the next digit and see that 7 is more than 2, and now we can say that the left number is greater. In the second, it's enough to count the number of digits of each of the numbers, and since the left one has more places, it will be greater in the inequality. The third point is interesting. We see that both numbers are 5-digit and both begin with 4. If we try to check the next digit, we will see that the right number has 9 and the left is unknown. So there can be any digit. It's important to understand that now we are already checking whether in any case the left number is less than the right one. In the first point, we immediately suspect that the left number is larger since it starts with 9 and the right one with an unknown number. Even if the unknown digit is 9, by passing to the next digit we will see that 0 is less than 1 and we will understand that the left number is greater than the right one. Let's write out the answers and move on to the last problem. In the number 5,789,231, 3 digits were crossed out so that in the digits that remained in the same sequence formed the smallest and the largest of the possible 4-digit numbers. For example, in order to create the largest number, we must put on the first place the highest possible number. In our case, we see that there is the number 9, and crossing out exactly 3 digits in front of it, we get the desired number. Reasoning similarly, in order to get the smallest 4-digit number, you need to put the smallest number in the first place. We will not be able to leave 2, 3 and 1 as the first digit because there are only 3 digits to be thrown, so we will leave the number 5 in the first place. Next, we must again select the smallest possible digit, and it's easy to see that this is exactly 2. And therefore, crossing out 7, 8 and 9, we get the smallest possible 4-digit number. Let's write down the answers and this will end the lesson.